Hello and welcome to Sensational Science. Today we're going to talk about neutron stars. Neutron stars are formed when a star at least 8 times larger than the Sun explodes in a magnificent supernova. The outer layers of a star would spread out and eventually disappear. However, the core of the star remains. Usually this would be the neutron star. The atmosphere of a neutron star is made out of hydrogen, helium and carbon. The outer crust is made out of ions and electrons. The inner crust is made of ions and superfluid neutrons. The outer core is made out of superconducting protons. However, the inner core material is still yet to be discovered. There are two types of neutron star. One is the regular neutron star. The other type is called a magnetar. A magnetar is much more dense than a regular neutron star, despite a neutron star already being very, very strong and much more dense than any other star in the universe. They are at least 100 times more dense than a neutron star. The magnetic force of planets and stars are measured in Gauss. Earth's magnetic force is around 0.5 Gauss. The Sun's magnetic force is around 1 Gauss. The magnetic force of a neutron star is at least a few trillion Gauss. It is so strong that it can fuse electrons and protons together. Only neutrons are left. Also, this means that if the Sun were replaced by a neutron star, it would very quickly gobble up all of the planets in the solar system. Also, they are rarely observable because the gravitational force can bend the light. A neutron star, despite only being 20 kilometers in size, has 1.4 times the mass of the Sun. 1 cubic centimeter of some neutron star weighs 400 million tons. This is basically like all of the vehicles in the US coming together at the size of one sugar cube. Neutron stars rotate 700 times per second. This means that the star moves through space at 1/5 of the speed of light. Usually, after a few thousand years, they tend to slow down. However, this does not always happen. Rarely, neutron stars meet another star. The neutron star would then orbit the fully formed star. Because of the massive magnetic field of the neutron star, it will then feed on the star's atmosphere. Eventually, they'll collapse in on each other. This will make a black hole. A pulsar is a neutron star with electromagnetic beams coming from the poles. This would usually make it a magnetar. If the pole faces the Earth, you can observe it with a telescope. The crust of a magnetar is usually under huge strain because of the huge gravitational force. A starquake usually happens to a magnetar. If the crust moves at any point, it creates a starquake. The crust of the star would erupt, causing its magnetic field to react. A starquake would basically be like a solar storm, something that happens to the Sun. However, the solar storm would be able to travel the entire galaxy. This makes it trillions of times more powerful than the strongest solar storm that the Sun could make. If a magnetar came to a black hole, the magnetar would still lose in the battle against the black hole, despite magnetars already being very powerful. The black hole would either swallow the magnetar whole or slowly dissolve it inside. As this happens, the magnetar would send huge gravitational waves through the universe, disturbing the curvature of space-time, a property of space near massive bodies, in which their gravitational field causes light to travel along curved paths. The black hole would then grow even larger in size and mass afterwards. If this was the massive black hole in the center of our galaxy, it would be large enough to gobble up the entire Milky Way. There are two possible future things that could happen to a neutron star in the future. It would either stay there and slow down a little, or it may collapse in on itself because of the mass continuing to build. When this happens, it turns into a black hole. Thank you for watching. Goodbye.